Dear students, so I am here with a new chapter, a very simple chapter, but yet a very important chapter from first, that is 11th standard inorganic chemistry. Okay, what is that? It is hydrogen and its compounds. Okay, so it is fully theoretical. So here we will be talking about hydrogen, dihydrogen, properties of dihydrogen and its various compounds. What are the different compounds of hydrogen that we have got to study? Look here, we will be starting with first dihydrogen, then we will study about hydrides, okay, hydrides and types of hydrides, okay. Next, then we will talk about water, okay, methods of okay, what methods of removal of hardness, okay, methods of removal of hardness. So we have got different methods. We know that water is of two types, soft water and hard water. We will understand how to remove the hardness of water, and then we will talk about what hydrogen peroxide. And lastly, we will talk about D2O. What is D2O? This is called as heavy water. So we will have to talk about all these compounds under this chapter. So now we will be starting with dihydrogen. Okay, students. So now let us start with hydrogen. Okay, atomic hydrogen. Yes. If I talk about hydrogen, okay, see, we know hydrogen, atomic number 1, mass number 1, okay, one of the most simplest atom ever in the periodic table, one of the simplest atom, a small atom, okay. How many number of protons? Okay, hydrogen consists of 1 proton, 1 neutron and 1 electron. Okay, hydrogen consists of 1 proton, 1 neutron and 1 electron. What is its electronic configuration? It is 1s1. The electronic configuration of hydrogen is 1s1. Okay, isn't it? Yes. See, understand one thing. Hydrogen is the most abundant element in the universe. Okay, it is the most abundant element in the universe. See, okay, on the surface of sun, hydrogen, okay, will undergo continuous fusion to form hydrogen molecule with the release of enormous amount of energy. Okay, now on the surface of sun, okay, surface of sun consists of majority of hydrogen, and okay, on the surface of sun, hydrogen will be continuously fusing to form hydrogen molecule, and it releases enormous amount of energy. Understand my point? Okay, it is the most abundant element in the entire universe, and its electronic configuration is 1s1. Okay, so in the nature, hydrogen exists in 3 isotopic forms. Okay, we know all this. Okay, in the nature, hydrogen exists in 3 isotopic forms. Okay, which are the 3 isotopic forms of hydrogen? Look at here. One is, okay, protium. Okay, second one is deuterium. Okay, and tritium. Okay, so hydrogen exists in 3 isotopic forms. Okay, protium, deuterium and tritium. Protium 1H1, okay, deuterium 1H2, okay, tritium 1H3. Okay, protium is denoted as P, okay, deuterium is, okay, denoted as D, and tritium is denoted as what? T. Okay, so in nature, hydrogen exists in 3 isotopic forms: protium, deuterium and tritium. Protium 1H1, deuterium 1H2, tritium 1H3. Okay, see, among these 3 different isotopic forms, okay, so 99.958% okay of hydrogen exists in the form of protium, okay, 0.015% 0.015% will exist in the form of what? Deuterium, and 10 to the power of minus 15% it exists in the form of what? Tritium. That means in nature hydrogen abundantly it is found in the form of protium, next deuterium, next tritium. And remember one more thing, tritium is the radioactive, okay, it is the radioactive isotope of hydrogen. It is the radioactive isotope of hydrogen. Understood? Okay. Yes. Since these isotopes differ in mass number. Okay. What is the mass number of this? What is the atomic mass of this? 1. What is the atomic mass of this? 2. What is the atomic mass of 3? The tritium 3. Since they differ with respect to mass, atomic mass, since the isotopes of hydrogen, okay, differ in atomic mass, okay, they largely differ in their physical properties. Okay, they largely differ in their physical properties. Are you getting my point? Okay, yes. So since they differ in their atomic mass, they have different physical properties, but almost their chemical properties are almost same. But they differ in their physical properties since they have different atomic mass. Okay, so that's about the different isotopic forms of hydrogen. Now let us talk about the position of hydrogen in the periodic table. Let us talk about the position of hydrogen in the periodic table. What about its position in the periodic table? Position of hydrogen in the periodic table. Okay, yes, this is one of the most most debated concept. Okay, we know position of hydrogen is uncertain in the periodic table. Okay, it is not fixed. Position of hydrogen is not fixed in the periodic table. Okay, it is placed as a separate element. It is placed at, if you can observe the periodic table, which one is the first element in the periodic table? Hydrogen is the first element in the periodic table, isn't it? Okay, yes. See, the position of hydrogen in the periodic table is uncertain. It is not fixed. It is placed as a separate element, okay, in the top of the periodic table. Correct? Okay. Why? Hydrogen does not belongs to any group. It is placed separately at the top of the periodic table. It is placed as a separate element. It does not belongs to any group. Observe here. Okay. Hydrogen resembles both alkali metals. Okay. Hydrogen resembles both alkali metals as well as halogens. Okay, yes, hydrogen resembles both alkali metals as well as halogens. That means hydrogen would have been placed in alkali metal group in the periodic table, or else hydrogen would have been placed under halogen group in the periodic table. But hydrogen does not belong to either alkali metal group or halogen group in the periodic table. It is placed separately at the top of the periodic table. You have to note this point. That means, in what way hydrogen resembles alkali metals? In what way hydrogen resembles halogens? See, okay, like alkali metals. Okay, what is the general outer electronic configuration of alkali metals? The general outer electronic configuration of alkali metals is NS1. Just like alkali metals, even hydrogen has the same electronic configuration of 1s1. Okay, observe here, sodium, which is an alkali metal, okay, it will lose one electron to form monopositive ion, isn't it? Okay, all alkali metals will lose one electron to form monopositive, monopositive ion. Just like this, even hydrogen will lose an electron to form a monopositive ion. Okay, see, that means, look at here, hydrogen is resembling alkali metals. Just like alkali metals, okay, it has the same electronic configuration of 1s1, okay, as alkali metals has ns1 configuration. Just like alkali metals, even hydrogen will lose an electron to form monopositive ion, okay. Whereas there is a difference. There is dissimilarity between alkali metals and hydrogen. What is this? All alkali metals are metals, whereas hydrogen is a non-metal. Okay. All alkali metals will have very low ionization enthalpy. Okay, isn't it? Okay, all alkali metals will have very low ionization enthalpy, whereas hydrogen has high ionization enthalpy. That means, in some way, hydrogen resembles alkali metals. In some other way, hydrogen has differences, okay, from alkali metals. Okay, are you able to understand my point? In the same manner, hydrogen also resembles what? Halogens. It also resembles halogens. Like, look here, okay. So, like halogens, see, we know halogens exist as diatomic molecules. Okay, isn't it? Yes, even hydrogen exists as a diatomic molecule. Hydrogen also exists as what? Diatomic molecule. Okay, halogens upon gaining one electron, okay, halogens upon gaining one electron, they acquire nearest noble gas configuration. Observe here, chlorine, upon gaining, chlorine, what is the atomic number of chlorine? 17. When it gains one electron, its electronic configuration, its atomic number becomes 18. That means it attains argon gas configuration. That means halogens, upon gaining one electron, they acquire the nearest noble gas configuration. In the same way, hydrogen also will acquire an electron, will gain an electron and acquire what? Okay, yeah, helium gas configuration, which is also noble gas. Helium gas configuration. What is the atomic number of hydrogen? 1. Upon gaining one electron, its atomic number becomes 2. That means it will attain helium gas configuration. Observe here, it is resembling what? Halogens. Just like halogens, even hydrogen will gain an electron to acquire the nearest noble gas configuration. Just like halogens, hydrogen will gain one electron to form monopositive ion, isn't it? Okay, mono-negative ion. Halogens will gain one electron to form mono-negative ion. Hydrogen will gain one electron to form mono-negative ion. In their mono-negative ion, okay, they attain nearest noble gas configuration. Say yes or no. Okay, just like halogens, even hydrogen exists as a diatomic molecule, but there is dissimilarity between hydrogen and halogen. What is that dissimilarity? Look here. Okay, the oxo acids, or else the oxides of halogens. For example, HOCl, the oxides of halogen. Okay, this is acidic in nature. Oxides of halogens are acidic in nature, isn't it? Whereas the oxide of hydrogen, which is the oxide of hydrogen, it is nothing but water. Water is neutral in nature, isn't it? Okay, oxides of halogens are acidic in nature, whereas oxides of hydrogen is neutral. That means, in some way, hydrogen resembles halogens, but in some other characteristics, it will differ from halogens. On the same lines, in some properties, hydrogen resembles alkali metals. In some other properties, hydrogen differs from what? Alkali metals. Okay, look at here, hydrogen is resembling both alkali metals as well as halogens. Okay, that means it would have been placed under alkali metal group or halogen metal group because of the dissimilarities, among alkali metals and halogens. Hydrogen is placed as a separate element in the top of the periodic table. It is the first element in the periodic table. Any doubts? Clear? So that's about the position of hydrogen in the periodic table. Now let us understand some of the methods of preparation of hydrogen. What are the different methods of preparation of dihydrogen. What are the different methods of preparation of dihydrogen? Yes. Okay. Methods of preparation of okay, dihydrogen, that is H2. Methods of preparation of dihydrogen. Okay. Yes. So you should know that hydrogen does not exist in atomic state. It exists as a diatomic molecule. Okay. Hydrogen does not exist in atomic state. It exists as a diatomic molecule. Now what are the different methods of preparation of hydrogen? First one, the first method, let me discuss. Okay. Preparation of dihydrogen from metals, or else by the reaction of metals with mineral acids. Okay, observe here. Yes. Okay, by the reaction of metals with mineral acids. When the metals reacts with mineral acids, they liberate hydrogen gas. Okay, are you getting my point? When the metals reacts with mineral acids, they liberate hydrogen gas. But not all the metals, when they react with mineral acids, liberate hydrogen. No. Okay, only observe the condition here. Only those metals whose electrode potential is less than the electrode potential of hydrogen, okay, can displace hydrogen gas from mineral acids. From what? Mineral acids. Okay, you will understand more about this clearly in 12th standard chapter called electrochemistry. Okay, understood? So understand this condition. Not all the metals will displace hydrogen gas from mineral acids. What is the condition? Only those metals whose electrode potential is less than the electrode potential of hydrogen can displace hydrogen from mineral acids. Can displace from hydrogen from what? Mineral acids. For example, look here. I have copper and zinc. Okay, two metals, copper and zinc. The electrode potential of copper is plus 0.34 volts. Okay, and the electrode potential of zinc is minus 0.76 volts, whereas the electrode potential of hydrogen is 0 volts. The electrode potential of hydrogen is 0 volts. Note this point. Okay, electrode potential of copper is plus 0.34, electrode potential of zinc is minus 0.76, electrode potential of hydrogen is 0 volts. Okay, that means among copper and zinc, which metal has electrode potential less than that of hydrogen? Okay, look here, the electrode potential of copper is more than that of hydrogen, isn't it? Okay, it is plus 0.34, 0 volts. Electrode potential of copper is more than that of hydrogen. That means copper cannot displace hydrogen from mineral acids. Okay, observe here, zinc, the electrode potential of zinc is minus 0.76, whereas the electrode potential of hydrogen is 0 volts. That means electrode potential of zinc is less than the electrode potential of hydrogen, isn't it? Okay, that means zinc can displace hydrogen from what? Mineral acids. Zinc can displace hydrogen from mineral acids. So like this, those metals whose electrode potential is less than the electrode potential of hydrogen, they can displace hydrogen from mineral acids. Okay, I will give you the electrode potentials of certain metals. You should remember that. Okay, now so that you will be able to understand which metal can displace hydrogen from mineral acids. Okay, mineral acids. Yes. Okay, let me write the electrode potentials of certain metals. For example, I gave you the electrode potential of what? Electrode potential of zinc. I told you it is minus 0.76 volts. Okay, isn't it? Electrode potential of lead. Electrode potential of lead, it is minus 0.13 volts. Okay, then electrode potential of Fe2 plus. Okay, it is Pb2 plus. Electrode potential of Fe2 plus is okay, minus 0.45. Okay, electrode potential of aluminium Al3 plus, it is okay, Al3 plus, it is minus 1.66, minus 1.66. So okay, look at this, all these metals, they have electrode potentials less than the electrode potential of hydrogen, which is equal to how much? 0 volts, isn't it? They, all these elements, all these metals, they have electrode potential less than that of what? Hydrogen. That means these elements can displace hydrogen from mineral acids. Which are those elements? That is zinc, okay, Pb2 plus, Fe2 plus, and aluminium. Aluminium, iron, lead, and zinc. These can displace hydrogen from mineral acids. Okay, let me write the reactions for it. Let me write the reactions. What are the reactions here? Okay, see this. First, zinc, when treated with sulfuric acid. Okay, when treated with sulfuric acid, it forms what? ZnSO4. And it liberates hydrogen gas. Look at here, we are getting hydrogen gas, dihydrogen. On the same lines, okay, 2Fe plus H2SO4, 3SO4 gives rise to what? Okay, so 2Fe2 SO4 thrice plus 3H2. Observe here, we are getting what? Hydrogen gas. So like this, we can prepare dihydrogen by the reaction of metals with mineral acids. On the same lines, we can also prepare okay, dihydrogen from base also. We can also prepare dihydrogen from bases also. Okay, that means when amphoteric metals, okay, react with base. Okay, react with base. Okay, yes, amphoteric metals means okay, those metals which react both with acids as well as base, like zinc, okay, lead, aluminium. Zinc, lead, and aluminium, they react both with acid as well as base. So though these metals are called as what type of metals? Amphoteric metals. So when these amphoteric metals react with base, there also we will get dihydrogen. For example, look here, when zinc reacts with sodium hydroxide, it will give what? Okay, Na2ZnO2 plus H2. Okay, what is this? This is nothing but sodium zincate. Okay, see, sodium hydroxide is a base. When zinc reacts with a base, it gives sodium zincate, liberating what? Dihydrogen. For example, aluminium, when it reacts with sodium hydroxide, it gives what? Okay, NaAlO2. This is called as sodium aluminate. Sodium aluminate liberates what? Hydrogen gas. It liberates hydrogen gas. Are we clear? Okay, next, tin, when it reacts with sodium hydroxide, I know this reaction is not balanced. Don't worry about balancing the reaction. Just observe here, when tin reacts with sodium hydroxide, here also we'll be getting what? Sorry, lead. Okay, Pb2Na or else Na2PbO2 plus H2. Okay, what is this? Sodium plumbate. Okay, so like this, when amphoteric metals reacts with bases, they liberate what? Hydrogen gas. Okay, if any metal whose electrode potential is less than the electrode potential of hydrogen can liberate hydrogen from mineral acids. So these are the two methods of preparation of dihydrogen. We have got two more methods of preparation of dihydrogen. Yes. Okay, what is the next method? See, if you want to get purest form of dihydrogen, okay, if you want to get purest form of dihydrogen, okay, then you have to carry out, okay, third method, to get purest purest dihydrogen, okay, dihydrogen, then okay, you have to electrolyze what? You have to electrolyze aqueous solution of barium hydroxide. Okay, when aqueous solution of barium hydroxide is electrolyzed, we will get purest form of dihydrogen. Understood? Okay, and the last method of preparation of dihydrogen, what is it? Okay, yes, what is our last method? Okay, yes, very important method. What is this important method? Okay, this is called as coal gasification. Coal gasification. Okay, yes, what do you mean by coal gasification? When steam is passed over, okay, red hot coke. Okay, when steam is passed over red hot coke, see what is going to form? Okay, coke means carbon. Carbon is in what state? Solid state. Okay, when you pass steam to this red hot coke, okay, see it will give carbon monoxide plus hydrogen. Carbon monoxide is a gas plus hydrogen is a gas. Are you getting my point? Okay, when steam is passed over red hot coke, it will give carbon monoxide and hydrogen. This reaction is called as coal gasification. And here, look at here, this mixture, the mixture of carbon monoxide and hydrogen, what is the ratio here? 1:1 ratio, isn't it? Okay, 1:1 ratio. See, the 1:1 mix now, 1:1 mixture of carbon monoxide and hydrogen. Carbon monoxide and hydrogen, this is called as water gas. What is this called as? Water gas. 1:1 ratio. But if there is 1:3 ratio, okay, if 1:3 ratio of carbon monoxide and hydrogen, then 1:3 ratio, this is called as, okay, synthetic gas or syngas. Synthetic gas or syngas. Are you getting my point? 1:1 ratio of carbon monoxide and hydrogen is called as water gas. 1:3 ratio of carbon monoxide and hydrogen is called as synthetic gas or syngas. Okay, yes, are we clear with this? Okay, see, this is according to old convention. But according to new convention, any ratio of carbon monoxide and hydrogen is called as syngas. Okay, according to new convention, okay, any ratio of carbon monoxide and hydrogen, this is called as what? Syngas. Okay, so guys, I'll stop my video here. I'll continue more about coal gasification, okay, and other methods of preparation of dihydrogen in the next video. Thank you.